there's this thing, when you grow up as a science enthusiast, right? Is like, it seems like the coolest thing to do, and it would be so awesome to be able to contribute to that. But everybody seems so smart, as Einstein,
Hmm.
Newton, all the people who did all these things. So can you really contribute something? And so one message that perhaps I would like to say is that, so this is something that, for many years I had this kind of questions, and everybody has them, or mostly everybody have these questions about, well, can you really contribute something, or you know are you good enough? Are there these
Yes.
can you contribute something meaningful, or is it just impossible? And one thing that I'm very happy to say is that I learned over time is that I think that image, like the image that science is done by a few geniuses, is wrong. If it was true in the past, in the 19th century and 18th, I think that's because, generically speaking, science was done. If it seems like only 10 people did science, was because there was probably 10 people worldwide doing science anyway. Because, in the 18th century, there was famines, war, it was
Yes.
19th century. So there were not that many people doing science. So one really beautiful thing that I think one discovers when one goes through the academic career is that it's really a very collaborative thing. And everybody can contribute, and can contribute, I think, really quite meaningful stuff, as long as you keep thinking about the big problems and are willing to work.
Right. So, was there, a book that you read when you were young that got you into physics, or no? I think you were just interested in physics from the very start.
Well, I mean, for sure there were some. There's maybe not a book that is just like.
Hmm.
Um, well, there's the you know there's a book by, I think it's Peter Atkins, which is called Galileo's Finger, which is just like it's just
Yes.
like a short book which tells you like different things about different sciences. Like, for instance, one of the things it describes is how Eratosthenes measured the circumference of the Earth. And I remember reading that and thinking, wow, that's so cool.
I see.
Um,
So,
uh,
so you just mentioned that people tend to think that science is done by geniuses, right? Uh, but one thing that a lot of people don't realize is that a lot of people that do very very good in theoretical physics, they do a lot of hard work. So hard work is really really important.
yeah,
When it comes to contributing. For example, even in our times, we have someone like Edward Witten, and people always say, "Oh, he's such a genius." A lot of people don't realize that he's a very hard worker, right?
yeah, yeah.
Right. So, what do you think about the importance of hard work as compared to just being a genius, right?
I think that was absolutely essential. And the moment, for instance, for me, when I sort of like realized, became convinced of what you were just saying, that it's really a lot more about hard work than about smarts, I became, very happy, because all these questions about can I contribute, they just became, yes, I just need to work very, very hard, right? Or need to work
Hmm.
hard. It's not like you should do whatever you like, but it's also not necessary to just push everything else in your life aside or anything like that. But you do need to work hard, and if it's something that you find interesting, um, that's why you should always try to work on things that you find interesting. Then it's not so hard to work hard.
Right.
And indeed, cases like Ed Witten, I'm sure you just, no matter how smart you are, you just look at this, at the amount of stuff he produces. Even now that he's, I think he's around 70 years old.
Hmm.
Uh, he's clearly someone who's absolutely passionate, and that is
Yes.
absolutely key.
Right. But do you think that another thing that is very important, and a lot of people struggle with this, is that if you want to produce something, meaningful to the the knowledge that we have about theoretical physics, you should also be prepared to fail again and again. And a lot of people get bogged down when they fail, right?
Yeah,
So what do you
that,
think
that
about that?
that's particularly true, because oftentimes, like, people who get in high energy theory, or in string theory or quantum gravity, they tend to be good students. So a good
Hmm.
student is someone who is used to the following situation. You have some challenge, which is the course material. You study the challenge. It may take more or less effort, but it's a finite amount of effort. Once you do this, you completely dominate the thing, and then you go to the exam, you get good grades, and you continue. Okay? Research is not like that. It's completely not like that. And so people who come from that background, they oftentimes have a hard time. uh, because they have not had to struggle, at least academically. But the point about research, is the way you make a lot of progress is, you need to try a lot of things, and a lot of them will fail, and then you try the next thing. And the fact that you fail doesn't mean you're dumb.
Mhm.
It means that you try something and it fails, so you need to keep trying. And if you keep trying, not only with each try, even if you fail to do whatever you wanted to do, you get better and better and better, even if you don't realize it. And eventually what will happen, for instance, if you're a PhD student, is you start doing things on your own, and at some point you have a very cool idea, and it was done by someone in the 60s. It's like,
Mhm.
okay, that's good. You're in the good track. You're just a bit late. And then you keep working, you keep thinking, and eventually you'll get something which is a good idea that you can work on, um, and it will work out. But it's all the time like that. And the thing is, one needs to learn to enjoy that process, which is fun in itself. It's like you think about something, seems curious, and the thing, if you care more about understanding what is going on in the problem at hand rather than whether it's going to be important or not, then you're going to enjoy the process a lot more, and the chances that you end up doing something maybe important are higher. But the more important thing is whether you do something important or not, you at least enjoy the process. Okay.
So this transition that you talked about, the transition that a student has from, taking exams to doing research, there is one more aspect about this transition, and I think I also talked about that in my previous podcast. Uh, the the problem is this. So when you are an undergrad, for example, right, and you are solving a problem from your book, or from a problem set, suppose that you're not able to solve that problem. You may take a day or two, and you're still not able to solve that problem. Now,
Yeah.
a lot of people in this particular scenario will think that, okay, probably I'm doing some mistake here. This problem is solvable, otherwise it would not be here, it would not be in my problem set, right? But then you go to grad school, okay, the problems may take longer, they may take weeks, right? But you still know that this is solvable, and I will be able to solve it in, like, probably at most a month, probably. But in research, you never know. The problem may
Yeah.
be it may be probably unsolvable for like one more century. You don't know about that, right? So
But
how does one deal with that when you go from being a student to being a researcher?
like it's like any other, really, like anything in academia is really no different from any other thing in the world. You just things sometimes take more practice than others. So the skill to realize when to continue working on something, when to give up, and more importantly, when to think, okay, what I did is not exactly what I wanted to do, but what is it good for? Can I
Hmm.
turn to that? So it's something that one learns with experience, okay, by doing more and more and more, and that's just it. But it's very it's important to keep that resilience, and to understand that that it's just it might have a solution, it might not. If you try for a while and it does seems like it doesn't have a solution, ask yourself, try to get it's very important to get physical intuition, very very important. If you're trying to solve something that doesn't have a solution, you say, okay, why what is the exact reason why this is not working?
Mm.
Try to get a physical picture. So that really helps a lot with deciding what to do. And oftentimes, even if what you want to do exactly doesn't work, there's something close related that you can do and it does work. Or the failure is telling you something which is even more interesting, perhaps they were interested originally. And this distinction that you were saying between problems that you know have solution and problems that don't, and how the first ones are the ones for undergrads and the others are for research, is really a distinction of time. I still have, I think, it's stuck in my mind. I remember I was many years ago studying like some condensed matter course, and there was a problem in a book. Unfortunately I don't remember the book, but there was this problem in this book, just some problem. It was not terribly difficult. Okay, it was not the easiest problem in the book. It was not the hardest, and it had a footnote which said, if you had solved this problem in 1967, congratulations, you could have published a PRL. Okay? And that's the entire difference. The calculation is not hard.
Yes.
The entire difference is what you were saying. In 1967, nobody knew this was an interesting calculation with a solution. And afterwards, people thought, oh, that's cute. I'm going to put it as a problem in my book.
Yes. I mean, that reminds me of a quote, but I think that quote takes things a bit further. But that quote is from Richard Feynman, so probably Feynman can say it. He said that there are two kinds of problems: easy problems and unsolved problems. And probably that's true to some extent.
There's another quote which is related, which I really like. I don't know who the quote is from. I just read it somewhere and it stuck, which is like, science is any endeavor in which the average people in one generation can get farther than the geniuses of the previous one.
That's true. Yeah, because they are standing on the shoulders of giants. That's why. So if you like this video, give it a thumbs up and consider subscribing, and the YouTube algorithm thinks that you will also like this video.